Welcome to Unit 8 of SAT Math, Geometry. Let's first take a look at angles. When parallel lines are cut by a transversal, parallel lines like A and M cut by a transversal T, alternate interior, alternate exterior, and corresponding angles are congruent. So alternate interior are angles like 3 and 6, alternate exterior are angles like 2 and 7, and corresponding angles are angles like 1 and 5. Those will be congruent. Adjacent angles are supplementary, so angles like 3 and 4 are supplementary, and vertical angles are always congruent. Vertical angles would be something like 1 and 4 or 2 and 3, angles that are opposite one another. So in the figure above here, we see that 1, 4, 5, and 8 are equal, 2, 3, 6, and 7 are going to be equal. Okay, let's look at question 1. Let lines X and Y be parallel, and let lines Z and W be parallel. If angle A is the angle formed by lines Y and Z, and angle B is formed by lines W and X, if the measure of angle A is 25 degrees, what is the measure of angle B? So we see that we're given here that A is 25 degrees, so we'll label that. And we see if we're trying to get all the way over there across the other lines to B, first thing we can do is we can see that there's a corresponding angle, here, that's also 25 degrees. And then we see that this angle will also be corresponding to this angle right here, which is also 25 degrees. And then you see 25 degrees is going to be supplementary to angle B, which means B is going to be 180 degrees minus 25 degrees, or 155 degrees. Okay, question 2. Two similar figures are shown below. In each figure, there are two vertical lines intersected by a third line. If angle A is 120 degrees, what is the value of angle C? So here we see that we have angle A as 120 degrees, and we are basically looking for this angle right here. This is the same thing as angle C. So given this, we see angle A and B are supplementary, which means angle B is equal to 180 minus 120, or 60 degrees. And then we see that B and C are now going to be alternate exterior angles, which means they are also congruent, which means C is also going to be 60 degrees. Question 3. Consider the figure below, which is formed by three intersecting lines P, Q, and R. If D plus E is equal to B plus C, which of the following must be true? So let's take a look at what we have here. We see that B and E are actually angles across from each other, or if we look back here, vertical angles. So since they're vertical angles, we see that B is going to be equal to E. And since we know that D plus E is equal to B plus C, this must also mean that D is equal to C. So now we can see that also, of course, other vertical angles are also going to be equal. So C and F, D and A. But let's take a look at our answer choices now. So 1 says D is equal to A. D is definitely going to be equal to A because those are vertical angles. So 1 is definitely true. Now let's take a look at the second one. It says E is equal to C. Now these aren't vertical angles. They are both in this equation here, but we can't determine anything. So we don't yet know if E is equal to C. And it seems like we don't really have the information to figure that out. So this one's probably going to be wrong. And then answer choice 3 says F is equal to A. And from here we can see that F is indeed equal to A because of what we've derived before, since we know that we have F is equal to C, and we know that C is equal to D, and D is equal to A. So writing that out, we see F is equal to C, C is equal to D, and D is equal to A, so F is indeed equal to A. So that means we have answer choice 1 and 3, so that's going to give us B as the correct answer. Okay, next we're looking at angles in a triangle. So the sum of the interior angles of a triangle is 180 degrees, and the sum of the exterior angles is 360 degrees. And what they mean by exterior angles is if you have something like this, a triangle like this, your exterior angles are going to be this one, and this one. So those are your exterior angles that sum to 360 degrees. The sum of the interior angles in any polygon, given that it has n sides, is n minus 2 times 180. So that's a little formula or equation that you should know. So question 4. Let angles Q equal 40 and R equal 70. What is the value of P? So here we see that R is given right here inside this triangle. And we see by vertical angle, this angle in here must also be equal to Q, which is 40 degrees. And we have R is 70 degrees. So we know that the sum of the interior angles of a triangle is 180, so which means this last angle must be 180 degrees minus 40 degrees minus 70 degrees, which is going to give us 70 degrees. So now we see that angle P and that angle 70 degrees are supplementary angles, so P must be equal to 180 degrees minus 70 degrees, which is the same as 110 degrees. Okay, question 5. What is the measure of angle FHD? So which one is FHD? Let's find that first. We have F, we have H, we have D right here, so that means we're looking for this angle right here. What is the measure of that angle if AB is parallel to CD? So AB is parallel to CD right here. JI is perpendicular to GF. JI is this line, GF is this line, so we can actually mark a right angle right here. And LE is congruent to EK. LE is congruent to EK, which means that these two lines are equal. We'll mark those off as well. So now that we have all of this, what we're looking for is that, let's not forget, we're looking for this angle right here. So a couple of different ways we can approach this. But the first thing, let's go off some of the information that we're given. We see that LE and EK are equal, which means that this right here is in fact isosceles triangle. And by vertical angles, we also know that this angle here is a right angle. So what this means for us is that these two angles are both 45 degrees. Knowing that these two angles are 45 degrees, we see that because CD and AB are parallel, we have alternate interior angles for this 45 degree angle right here alongside this angle right here. Excuse me, trying to get it in there. So this is also 45 degrees by alternate interior angles. And because this, again, is 90 degrees, this is 45 degrees, finding that we just have 180 degrees minus 90 degrees minus 45 degrees will give us our desired FHD, which of course we know now to be 45 degrees as well. Okay, question 6. In the figure above, the center of circle O lies on the circle P, and the center of circle P lies on the circle O. Which of the following is the value x in degrees? So first, this one looks kind of tricky. We don't really see a lot of angles being given here, so what can we do? First of all, we know this right here, O to its edge, this is a radius, right? So that must be true. And this must also be a radius. So now that we have two radius, we also know that this must be a radius. So if all three of these sides of this triangle we just drew are radii, that means they're all the same length, which means that this is actually an equilateral triangle. So all of the angles in an equilateral triangle are of course 60 degrees, so x must in fact be 60 degrees D. Okay. Congruence and similarity. So there's a couple of different rules for congruency. That's SAS, ASA, AAS, and SSS. So what this means is that S, of course, stands for side, and A, of course, stands for angle. So to prove congruency, we can show that two triangles have a side, an angle, and a side, of course, in that order. So two sides with an angle in between that are the same. Also, you can prove it by two angles with a side in between are the same, or two angles and a side are the same, or three sides are the same. All of these prove congruency. So now, similar triangles. All you need for similar triangles are two angles to be the same, or this is the same, of course, as having three angles being the same. And having the same angles means there's proportional sides, so these triangles will in fact be similar. Okay, question 7. The figure on the left is congruent with the figure on the right. If A equals 115 degrees and B equals 45 degrees, what is the value of C? So, first of all, since they're congruent, let's draw C into this diagram on the left. C is right here, which means C must also be right here in this diagram. So, now if we know that A is 115 degrees and B is 45 degrees, what can we figure out? Well, we see that this angle right here is supplementary to angle A, which means that this angle right here is 180 minus 115, which is the same thing as 65 degrees. So now we have a triangle here with 65 degrees, 45 degrees, and C. So that means 180 degrees minus 45 degrees minus 65 degrees should equal angle C, which of course, if we do the algebra for that, we see that we get answer C, or 70 degrees. Okay, question 8. Let lines A and B be parallel in the xy plane. Line A has an x and y intercept of -6 and 3, respectively, and B has a y-intercept of -4. What is the x-intercept of line B? So let's go ahead and draw this out, just to visualize things. So first of all, we have line A with an x-intercept of -6. So that's somewhere over here. And a y-intercept of 3. And that's going to be somewhere here. So this is the line that we have for x. And now we see that, or for y, sorry. For line A, sorry. And then line B has a y-intercept of -4, which is going to be somewhere down here. And we are looking for its x-intercept. So if we know that these two lines are going to be parallel, we can draw the line somewhat like this, and we see that our x-intercept for line B has to be somewhere here. Now, of course, where is that? Let's do this by finding the slope of the line for A. So what we have is point -6, 0, and 0, 3. So, of course, finding the slope for this, that's going to be 3 minus 0 over 0 minus -6. So that's going to be slope of 1/2. So that means B must also have a slope of 1/2. Having a slope of 1/2, given that we have this one point here of 0, comma -4, means that we must have an x-intercept of, we'll call it x, comma 0. Must also have a slope of 1/2. That means 1/2 is going to be equal to 0 minus -4 over x minus 0. So that's, of course, just x. So 1/2 is just equal to positive 4 over x. So doing the algebra here, multiplying x over, and then multiplying the 2 over, so we see that we get x is equal to 8. So answer choice C. Okay, question 9. A gardener wants to build a bridge across a pond, but she does not know the length of the pond x. Her sketch is shown below. The lengths represented by PO, QO, OM, and MN on the sketch were determined to be 1,600 feet, 1,200 feet, 800 feet, and 500 feet, respectively. So let's go ahead and write those in. PO is 1,600, so that's right here. QO is 1,200, so let's write that in right here. OM is 800, let's write that in here. And MN is 500, so that's right here. So now, of course, we are looking for our side x, right? They say that segments PN and QM intersect at O. We see that. PQM and MNP have the same measure. So that's just here, PQM and MNP. So that's this angle here. Okay, so now we see what we can do is we can look for relations between these two triangles. Given that we know that these two angles must be the same since they're vertical angles, and that this angle must be the same as this angle, that means we in fact actually have all the angles the same. So these two triangles are actually similar, meaning if they're similar, we now know that we can relate them. So seeing the relations between the sides, we see that we should have ratio of OM over QO to be the same as MN over X, or PQ. So now, since we know that OM is 800, QO is 1,200, we have basically 800 over 1,200 is equal to 500 over X. And of course, 800 divided by 1,200 is 2/3, and 500 over X then also needs to be 2/3, which means X is going to be equal to 750 feet. Question 10. If MN is parallel to FG, if CD is parallel to AB, LE is congruent to EK, JI is perpendicular to FG, and angle AOJ is 65 degrees, what is the measure of angle JOM? So clearly we have a very complex diagram here and a lot of information being thrown at us. So let's take it one step at a time. First, which angle do we want? We want JOM, which is this angle right here. So let's just remember that this is the angle that we're looking for. Now, what do we have? MN is parallel to FG. That just means that these two are going to be parallel lines. So we know those two are parallel lines. We'll just label this like this. CD is parallel to AB, so we can just label these two as well as parallel. And we know that. Now we see that JI is perpendicular to FG. So JI and FG, that just means that this is a right angle right here. Right here. That will be a right angle. And angle AOJ is 65 degrees. So that's this angle right here. So that's 65 degrees. So now we have a couple of things that we can work with. Since we see AOJ is so close to the JON that we want, let's start working from there. Well, we know because AB is a straight line, that means that this whole thing right here must be 180 degrees. So this must be 180 degrees, which means if we can figure out this angle in here, we can subtract 65 and that angle to get our JON. So let's see what we can do. We see that LE is congruent to EK. That just means that these two are going to be congruent. So this is an isosceles triangle. And since we know that this is 90 degrees, that means that these two angles are both going to have to be 90 divided by 2, or 45 degrees, just like this. So now what do we have? We have that, so we can see that by vertical angles, this in here also needs to be 45 degrees. Let's go ahead and label that. That is 45 degrees. Now, we're super close. We have this angle in here, but we still have two other unknown angles in this little triangle right here. So what can we do about that? Well, we see that because MG are parallel, and we see that JI is perpendicular to FG, we must know that JI is also perpendicular to MN. So what we see is we actually have a right angle right here, which means we also have a right angle in here. So what this means is that if this is a right angle, this is 45 degrees, then this must also be 45 degrees. So now what do we know? We know this angle, and we don't know this angle, but we know that they sum up to 180 degrees. So what we can do now is we can write 65 plus 45 plus angle JON is equal to 180 degrees. So doing a little bit of math here, we see that if we subtract 65 and 45 from 180, we get that angle JON is equal to 70 degrees. And that is going to be our answer. Okay, now let's look at volume word problems. The volume of a prism is its area of its base times its height, whatever that area might be. For example, if you have a cylinder, this is a circular prism, so you take pi r squared, which is the area of the base, which is a circle, times the height of the cylinder, h. Okay, question 11. A bread loaf pan's shape can be approximated by a right rectangular prism 10 centimeters long by 20 centimeters wide by 10 centimeters high. If the pan contains 500 cubic centimeters of dough, approximately how far is the dough from the top of the pan? So if we draw a quick little sketch, we see here that we basically have a pan that'll look like this, and then we'll have some dough that's taking up some amount of space here at the bottom. And basically we're looking for this distance here. So we know that the rectangular prism is 10 by 20 by 10 centimeters high, which means it has a volume of 10 times 20, which is the base, times the height, which is 10, or 2,000 cubic centimeters. So knowing that we have this, we know that the pan contains 500 cubic centimeters of dough. 500 cubic centimeters of dough is 500 over 2,000, or 0.25 of the height, of the total volume, which means it's also a quarter of the height since it fills up layer by layer starting at the base. So it means we are still 3/4 of the way of from the top of the pan. So the dough is still 3/4 of the height from the top of the pan, which means 3/4 of 10 centimeters is of course 7.5 centimeters, or answer choice D. Okay, Eleanor ordered a massive gift online, which will be delivered in a cube-shaped gift box with a volume of 27,000 cubic inches. In order to purchase enough wrapping paper to cover the box, she must calculate its surface area. What is the surface area of the box in square centimeters? So, since we know that the volume is calculated it's because we have a cube, it's going to be its side length cubed. So, assuming that each side of the box is x cubed should equal 27,000. Which means x, if we take the cube root of 27,000, is just going to be 30 inches. So it's a 30 inch by 30 inch by 30 inch box. And if we want the surface area, that for a cube, that's just 6 times each area. Because there's 6 sides, the area of each side is going to be 30 inches times 30 inches. So this is now, we have the area of each side times the number of sides, and that's going to give us a total of 5,400 square inches, or answer choice D. Okay, question 13. Suppose there's a water tower whose water storage area is shaped like a right circular cylinder, as shown below. Let the volume of the water storage be 36 pi cubic yards, and the height of the water storage area be 4 yards? What is the radius of the base of the cylinder? So we know that the volume is 36 pi cubic yards. And if we set this equal to what we know to be the equation for the volume of a cylinder, it's pi r squared times the height of the cylinder. So what do we know from here? First, we see we have a pi on both sides, so we can cancel that. Now we have 36 is equal to r squared times the height, which we're told is 4 yards. So let's put 4 in there. Now dividing both sides by 4, we see we're left with r squared is equal to 9, which means that our radius is going to be equal to 3 yards. Okay. Volume of a pyramid. So the volume of a pyramid is the area of the base times the height of the pyramid divided by 3. And for a cone is essentially a circular pyramid. So what we're going to do is going to take the area of the cylinder, or pi r squared h, and then divide that by 3. So question 14 says, there is an ancient square pyramid with side lengths of 220 meters. The original height of the right pyramid was estimated to be 150 meters tall. Because of erosion, the pyramid is currently 141 meters tall. Approximately how much did the volume, measured in cubic meters, decrease since it was built? So first, let's look at what was the original volume of the pyramid. The original volume of the pyramid is going to be the base, which is 220 by 220, so 220 times 220, times the height, which was originally 150 meters. And of course, we have to divide this by 3. So this is the original volume of the pyramid. Now, let's subtract the current volume of the pyramid. Still 220 by 220 as for the base, but now the height is only 141 meters. And of course, we divide that by 3 as well. So this will give us the decrease, so the difference in volume. And of course, since these two are very similar, we see that we can factor this out. So we get 220 squared over 3 times 150 minus 141. And this is still equal to the difference. And if we calculate this out, we see that we get a difference of 145,200 cubic meters. So answer choice C is correct. Okay, question 15. Suppose there's a cylinder with a cone with radii of equal length and equal volume. If the height of the cone is 72 centimeters, then what is the height of the cylinder in centimeters? So the big thing here, looks like we might need to do some math, but let's just think through it first. We have cylinder and cone. So the area of the cylinder is pi r squared h. Area of the cone is pi r squared h over 3. And we know that they have a radii of equal length and they're of equal volume. So we know the height of the cone is 72 centimeters. So let's move this down and say that this is pi r squared times 72 over 3. And this actually has to be equal to pi r squared times the height of the cone itself. So first of all, we can start canceling things, but we also know that because the difference in volume of a cone and cylinder, the difference in the equation is just a factor of 3, that means in order to have the same volume, there must be a 3 times difference in height. So which means the cone must be 3 times as tall as the cylinder for them to have the same volume. But let's see how this works out in math. Since we know the radius is the same, we can cancel that out on both sides. And since pi is always the same, we can cancel that out as well. So we now have our height is equal to 72 over 3, which of course is the same thing as 24 centimeters. Okay, question 16. A chemistry student adds 12 cubic centimeters of sand into a rectangular prism with a square base of side length 4. She then adds 120 grams of salt and 24 milliliters of water. At this point, the prism is 3/4 the way full. Assuming that the crystals have a density of 5 grams per cubic centimeter, what is the height of the prism? So this one's got a lot of moving parts, but let's make an equation where we bring all of our information together. So first, what is the volume of our solution, of our total, solution that we were working with here? We know that it's a rectangular prism with a square base of side length 4. So that means our base is 4 squared times our height, h, we'll call it. However, remember, we're only 3/4 full. So let's call it 3/4 h. So that's our total volume of our solution. And we know this is going to be equal to whatever we added in. So first there's 12 cubic centimeters of sand. So let's add 12 cubic centimeters. And then let's go ahead and add our 24 milliliters of water. And we know that 1 milliliter of water, let's just write this down. 1 milliliter of water is equal to 1 cubic centimeter. So this is just 24 cubic centimeters of water as well. And the last one is the tricky one. We add 120 grams of salt. However, we know that they have a density of 5 grams per cubic centimeter. So let's go ahead and do 120 grams divided by 5 grams per cubic centimeter. So now this is our equation. As you can see, we have all numbers on the right-hand side, and we just have that one variable h of that height that we're looking for on the left-hand side. So solving for this, we can see that we can simplify this a little bit. We have 16 divided by 4, that's 4 times 3, that's 12 times h is equal to 36 times 120 divided by 5, which is 24. And we see, once we solve this out, we get h is equal to 5. And we are looking for the height of the full prism itself, not the height that we filled it up to. So h being 5 is the correct answer. A. Okay, right triangle word problems. Big thing to remember here is that a squared plus b squared equals c squared. This is Pythagorean's theorem. You should note this. And remember, c is always the hypotenuse when you do an equation like this. So let's scroll down. Question 17. Brian wants to hang a nice painting on the wall between two windows such that the longer side of the painting is horizontal. The windows are 42 inches apart horizontally, and the painting is approximately twice as wide as it is tall. Of the following, which is the longest that the diagonal of the painting could measure of the following options and still fit between the windows? So we see that we are 42 inches apart horizontally and approximately twice as wide as it is tall. What that means is we have a painting that is 42 by 21. So let's go ahead and use Pythagorean's theorem. We know that 42 squared plus 21 squared must be greater than our diagonal, we'll call it c, just because that's Pythagorean's theorem, c squared. That must be greater because this is the maximum dimensions. Your maximum dimensions horizontally is 42, and that means the painting is going to be 21 vertically, so it can't be bigger than this hypotenuse that we're calculating. So what does this equal? Once we take this and we square root both sides, we end up seeing that this is about equal to 46.96 is greater than c, which means c has to be less than 46.96, and the only answer that suffices this is answer choice A, 35 inches. Okay, question 18. An SR-71 Blackbird airplane is 5 miles from the airport runway when the pilot begins descending at 12,000 feet. How far in miles does the plane actually travel during its descent? Recall that there are 5,280 feet in 1 mile. Round and answer to the nearest tenth of a mile. So we have our plane up here, let's call it, and then we'll have our runway down here. So let's draw out this triangle that we know we have. So this is the distance it actually travels. This is what we're looking for. And we are 5 miles from the airport runway, so we'll call this 5 miles. And we are 12,000 feet in the air. So converting that to miles, we have 12,000 feet divided by 5,280, which gives us about 2.27 miles. So now using Pythagorean's theorem, we see that we'll call this x actually, just for clarity. This is x. So we have x squared is equal to 5 squared plus 2.27 squared. So now once we solve for this, we get x to be about 5.5 miles. So that would be the actual distance that the plane travels to descend. Okay, looking at special triangles, we see that these are two of our key triangles that we should keep in mind when solving problems. We see that right here we have the 45, 45, 90 triangle, where it's isosceles, of course, so both legs are of length x, and the hypotenuse is of length square root 2 times x. And if we see the triangle on the right here, this is our 30, 60, 90 triangle, also very important. And these sides are a little bit different. We have x for the shortest side, 2x for the longest side, and then square root 3x for the middle side. And maybe a key way you can remember this, if it helps you at all, just know that there are two sides the same. In this one, you have your isosceles triangle, so there's going to be that square root 2x. For this one, there's going to be all three sides are different, so you're going to have that square root 3x for that middle side. Question 19. The large triangle below has a vertical line of symmetry in the middle. Half the length of the base y is 4 feet. Angle QRP is 30 degrees. Approximately how tall is the large triangle? So we see we have this large triangle here, and we see we have this PQR triangle in here. We see that this big triangle shares this angle with PQR. So if we draw PQR like this, where we have P here, R here, and Q here, this being a right angle, we see that PQR looks more similar to this half of this big triangle. And we know that QRP right here is 30 degrees, which means that angle P over here must be 60 degrees. And so must that be of the big triangle. Since they're similar, we know that this big triangle is a 30, 60, 90 triangle, because this is going to be 30 degrees, and we know that this is 60 degrees. So what this means is if we label the height h, we know that this being 4 feet, by 30, 60, 90 rules we just learned, h square root 3 should be equal to 4. So now doing a little bit of algebra, we see that h is equal to 4 over square root 3, which is the same thing as about 2.3 feet. Okay, question 20. A merry-go-round is shaped like a regular hexagon with a side length of 6 meters, where each corner represents a carriage containing a passenger. To let passengers on and off, the ride stops every 10 minutes at a corner or carriage reaches the ground level. 5 minutes after the ride starts, what is the height of the top carriage from the ground? So we're basically looking for the height of this carriage or this carriage, it's the same thing, from the ground. So we're looking for this distance right here. Okay, so what do we know? We know that each of these side lengths is 6. This is given. And also because it can reach like this, that this must also be 6. So this length is 6. So what we have this 6 right here already. And we just need to find this distance right here. We'll call this x. Once we find that, our height is basically just going to be 6 plus x. And that's going to be our answer. So what is this x? Let's draw this triangle right here. We know this is an equilateral triangle. So we'll redraw it right here. So each of the side lengths is 6. So now that means that if we split this down the middle like this, what we're left with is actually a 30, 60, 90 triangle, because this is the 60 degrees, this is 60 degrees, this is 90 degrees, and this has to be 30 degrees. And because we split it down the middle of an equilateral triangle, this length must be 3 right here. This base right here must be 3. So what does that tell us? That tells us this, we'll call this y, this height y is just going to be 3 square root 3 by the 30, 60, 90 rule, since we know that the base is length 3, which means that this is going to be our x value. Sorry, meant to label this as x. That means x is equal to 3 square root 3, and our height is going to be equal to 6 plus 3 square root 3.